All right, algebra class. This is 9.7, solving systems of linear and quadratic equations. Now, I chose to separate out these last few sections of Chapter 9 because I thought Chapter 9 was just a little bit intense to have a test over, all of this stuff. But so the next test will only have these three sections, 9.7, 9.8, and 9.9. So to begin with 9.7, we're solving systems of linear and quadratic equations. Okay, so we're going to look at a system of equations where we have a line that intersects with a parabola, a quadratic. So as you can imagine, there's a lot of possibilities for that to happen. Okay, so let's just talk about a few of them before we get into this too much. One possibility is we could have a parabola that looks something like this, and we could have a line that looks something like this. Okay, if this is the scenario that happens, then we have exactly one place where that line touches the parabola, and that happens at the vertex. So this would be an example of a picture of one solution. Okay, a solution of a system, you guys, remember, this is kind of a review. To solve a system, we are looking for a place of intersection between two different things, between the line in this case and the parabola. Okay, so they only intersect at this one spot. You could also have, I guess I should keep the theme here, you can also have an instance where we have like a parabola, and then we have a line that has a slope that goes through here. Okay, that's a terrible line. Something like this, right? So in this case, we have these two solutions. So there's a two solution possibility, a one solution possibility, and then we have another one. We have this possibility where we have something like this with this, right? Where there will never be an intersection. This would be a no solution to the system. All right. Individually, they might have a solution. Like this line would have a solution at, wherever it crosses X. But when we're talking about a system, we're looking to see where this, like the solution of a system is always where the two things cross, where the two pieces cross. Okay, so where we have two different graphs that cross each other. All right, so steps to solving by graphing. First of all, we're going to graph the equations independent of each other. Then number two, we're going to find the coordinates of each point of intersection. So if you're following along in your notes, intersection goes there. And then step three, we are going to check our solutions by substituting our x and y back in to see if it makes sense. All right, so let's try this out. So here's example one. It says to solve this by graphing. So here's a review. Let's start with the easy one. Y equals x plus 3. So the slope here, hopefully you identify as the number that is out in front of x, which is 1. Okay, so we're going up 1 over 1, up 1 over 1, beginning at our y-intercept, which is at positive 3. So we'll start at positive 3 here. We'll go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and then we can go down 1, back 1, down 1, back 1, down 1, back 1, and so we have this kind of a line happening. Okay, so there's our line, and now our task is to see if it intersects this quadratic. Okay, so we have to go back to last chapter where we graphed quadratics. This thing has a y-intercept of -5, so I know I have a point right here. Okay, and if I'm going to graph that, one of my first steps in graphing that is going to be to find my vertex. Okay, so where is my low point? So to start with that, I'm going to do my axis of symmetry, which is x is equal to -b over 2a. Okay, so in this case, b is -1, so we have -1 over 2 times 1, okay, which is 1 over 2, 1/2. So at 1/2, I have symmetry. So 1/2 is somewhere in here, okay, somewhere in here. And then if I plug a half back in, I'll know exactly where my vertex is. So 1/2 squared is 1/4 minus 1/2 minus 5. So 1/4 minus 1/2 is -1/4, minus 5 is -5 1/4. So I'm right in there somewhere. Okay, and I know that point there. Okay, so now I kind of have an idea of my shape, right? But I got to see where it crosses that line. So now I'm going to choose a couple of values to plug in. Okay, so here's x, here's y. I'm going to choose my x values and see what I get out for y. Okay, so I'm going to be smart about what I choose. I may want to see what happens at 2. So if I plug a 2 in, okay, so plug a 2 in, and again, I'm graphing this one right now, so I'm going to plug a 2 in for x there. I get 4 minus 2 minus 5, right? 2 squared is 4, minus 2 minus 5. 4 minus 2 is 2, 2 minus 5 is negative 3. So if I plug a 2 in, I get negative 3. Okay, so I'm right there. Okay, that means that if I go, see this line here is at a half, right? So I want 1.5, so if I go 1.5 on this way, I'll be right here. Going to the other side. Okay, so I got to go further to intersect that line. Let's try out, I'm not sure where 3 will do, but let's try 3. If we plug a 3 in, 3 squared minus 3 minus 5 is 9 minus 3 minus 5. 9 minus 3 is 6 minus 5 is equal to 1. So at 3, I'm at 1. Okay, and again, this space right here, okay, because remember this is the axis of symmetry, right? So it's the same on both sides. That is equal to 2.5 in this case. So at 2.5 going the other way would put me right in here. So I may have an intersection there. Okay, so I may have an intersection at negative 2, comma 1. Okay, it appears that I do, but we'll check it. Okay, so it appears that this intersection is at negative 2, comma 1. And again, I found that because I just counted backwards 2.5 from a half, and I was at negative 2. Okay, let's keep going because I got to see what happens with my other intersection. Let's plug a 4 in. So if I plug a 4 in, I would get 4 squared, which is 16, minus 4, minus 5. 16 minus 4 is 12, minus 5 is equal to 7. So at 4, I'm at 7. And what do you know? We know that that's for sure an intersection because that was on my other line, right? Okay, so there we go. We don't really care too much about the other side because there's no intersections, but it appears that 4, comma 7 is also a solution. So now I got to check it, right? This is x, this is y, this is x, this is y. Let's plug those things back in. So I'm going to switch colors to green here just to check myself so the check is in green. Okay, so if I plug a 4 in for x, I already know I get a 7 out of my quadratic, but let's check my other equation. So I'm going to check this guy into my y equals x plus 3. So that would be 7 is equal to 4 plus 3. Again, I just took this equation, and then I replaced y with 7, and I replaced x with 4. Okay? All right, so I'm checking to see if that works. That does work. I'm good. Okay, so I'm going to check my other one. Negative 2, comma 1. So I'm going to check this in both equations, okay? So if I plug it into my first one, I'm going to say 1, because my y value, is equal to negative 2 squared minus negative 2 minus 5. Okay, so negative 2 squared is 4. 4 minus negative 2 is, well, we can just say 4 plus 2 minus 5. Okay, so that equals 6 minus 5. So sure enough, we get 1 equals 1. Okay, plug it into my other one. So 1 is equal to negative 2 plus 3. And that works as well. So those are my two solutions. Negative 2, comma 1 and 4, comma 7 are my solutions. Okay, that's example 1. Example 2, you guys are probably thinking there must be an easier way. Yes, there's an easier way. We do not have to solve these by graphing every single time. All right, so we don't need to make those pictures, but they do exist. You can also plug these in Desmos to check those, so feel free to do that. The second part of this lesson is solving algebraically. So to solve algebraically, what I want you to do is I want you to solve each equation for the y value. Okay, so solve for y. Substitute one expression for y into the other, and then we're going to solve for x. substitute the x values in either of the original equations to solve, step 5, solve for the y value in the other equation. Okay, so we solve for y, plug everything in, get x, plug x back in, and then solve for y. Sounds confusing. Why am I solving for y twice? Well, you'll see here in an example. So let's do one together, but let's refer back to these steps, okay? So if you need to, refer back to those steps, which hopefully you have in your notes. So here's example 2. Okay, so the thought process is we're going to solve both equations for y. This one already solved for y, but this one is not. So I'm going to solve it for y. So 2y minus 16 equals 6x. I'm going to add 16 to both sides to try to isolate my y, right? So 2y is equal to 6x plus 16. I added 16 to both sides. Okay, and then to get y by itself, I have to divide by 2 since it was being multiplied. So I have to divide everything by 2. So y is equal to 3x plus 8. Okay, so now that I have this, okay, so we've done the first one. We're going to substitute this expression into my other equation for y. Okay, so I'm going to go ahead and do that. I'm going to plug that guy in. So wherever I see a y, I'm going to plug in 3x plus 8. Okay, so here's the next step. We'll change colors. So the only place I see y is here. Okay, so I'm going to plug that in. 3x plus 8 is equal to x squared minus 5x minus 12. Okay, so now I'm going to solve this. Okay, so I'm going to combine like terms. And this is a quadratic, right? So I'm going to be factoring at some point, trying to figure this thing out. Okay, so let's combine like terms. So let's go ahead and subtract 3x minus 8 from both sides. So subtract 3x and 8 from both sides. That makes this go to 0. And over here we have x squared minus 8x minus 20. Okay, we just subtracted 3x and we subtracted 8 from both sides. All right, so now we're going to factor this to find my two possibilities, okay, for x. So if I do that, I'm looking for two things that multiply to give me negative 20 and add to give me negative 8. So 1 and 20 doesn't work. 2 and 10, oh, that could work with a negative 10 and positive 2. Okay, so this would factor to x plus 2, x minus 10. Okay, and if you're unsure about that, you could FOIL it out, and you should be getting x squared minus 8x minus 20 when you FOIL it back. Okay, and so the two possibilities for x here are the things that make this go to 0. Right? So the things that make that go to 0 are negative 2 and 10. Okay? So those are my two x possibilities. I'm not quite done because the place of intersection, you guys, is always going to be a coordinate, right? It's a coordinate. It's an intersection. So these are my possible x coordinate intersections. Then I have to, so I've done this, right? I've substituted in, I solve for x. Now, I'm going to take those x values and I'm going to plug them back into either equation, either one of my original equations for x, and it'll give me my y. I always like to go into the linear equation because it's a lot easier. So I'm going to go into my linear equation here. And again, I'm just solving this equation, plugging negative 2 in for x, and then plugging 10 in for x. So let's do that. So 2y minus 16 equals 6 times negative 2. And then my other one would be 2y minus 16 is equal to 6 times 10. So I just plugged in these guys for my x value in this equation. Okay, so let's solve that out. So I get 2y here is equal to, let's add 16 to both sides. So we have 16 plus negative 12, right? Okay, kind of skipping a step there. So negative 12 plus 16 gives me 4. And when I solve this, I get 2. Divide both sides by 2. Okay, so when I plugged in a negative 2 for x, I got a 2 out for y. All right, so one place of intersection is negative 2, 2. Okay, and let's do the other one here. So we have 2y minus 16 is equal to 60. Let's add 16 to both sides. So 2y is equal to 76. divide both sides by 2, y is equal to 38. So when I plug a 10 in, I get a 38 out. And again, that is true in both equations. So these are places of intersection. Okay, focusing on the intersections. That's example 2. Example 3, so there might be remember that there might be one that has no solution. So this is one of those where, the graph, each graph is perfectly legitimate, but they never touch each other. Okay, so this was an example of what that would look like if you were to solve it algebraically. So we're going to follow our same steps. This is solved for y, let's solve the other one. So y would be equal to, let's add 3 to both sides, right? So x plus 3. Then I'm going to take that and plug it back in for that y. So we have x plus 3 is equal to negative x squared plus x minus 1. Okay, then we're going to combine like terms. So I'm going to subtract x and 3 from both sides. Okay, when I do that, this goes to 0. The other one goes to negative x squared. The x's cancel. Then we get negative 4. Okay, so when I go to solve this, I have to be able to factor this guy. So there's a lot of ways we can factor it. The first thing I always ask myself is, can I take anything out of both terms? And I can. I could take a negative 1 out, right? So I'm left with x squared plus 4. All right, so 0 may be a solution, but only if this thing factors. So can you factor x squared plus 4? And the answer to that is you can't. This is the sum of 2 squares, okay? And if you don't know that, what you might want to do is plug this into the quadratic formula, right? Our a value is 1, our b value is 0, and our c value is 4. And what you'll end up with is you'll end up with a square root of a negative number. Okay, so you can do that out, but just know that if you have the sum of 2 squares, that thing never factors. Okay, so if it does not factor, the answer is no solution. And a nice way to check yourself with technology would be to plug both of these into Desmos, plug them into desmos.com, plug them in and see if they intersect each other. And you will see in this case that they do not. All right, guys, the homework, I have homework sheets posted for you guys. Ask questions next time in class, and we'll see you next time.